Hi everyone. Today's topic is the factored form of a quadratic relation. Today we're going to talk about finding the zeros. So you know from our first spiral in the course that we talked about the standard form of a quadratic equation or relation rather, and here it is. Y equals ax squared plus bx plus c. So just a quick reminder that c is the y-intercept and a is this strange number. It's kind of like a slope, but not really, in that it tells you whether the quadratic opens up or down, and it also tells you about the shape. So this new thing that we're going to talk about today is the factored form. And the factored form still has that a value. So whatever a value you had up here, same idea down here. That a value is there, and it still tells you about the opening, whether it opens up or down, and what the shape of it is. But we've now got these two things, this multiplication, and you're going to see that these things here tell us about the zeros. Okay, so that's what we're going to do today. All right, let's start off with something that I know you can do. I would like you to pause the video just for a moment and figure out what is the a value of this relation. So I just want you to work out the a value of this relation. Pause the video and work it out, okay? Okay, did you figure it out? Hopefully you did, but if not, remember how we find the a value. We first need to find our first differences. So for this one, we work out our first differences. That's 5, that's 3, that's 1, that's -1. That's -3, and that's -5. Okay, so there were our first differences. And then from here we do our second differences. That's 2, that's 2, that's 2, that's 2, and that's 2. So our second differences equals 2. And if you remember, we had this little formula that the a value, equals the second differences divided by delta x squared divided by 2. In this case, delta x is 1. Okay, so in other words, the a value here, if you put everything in, your a value is going to equal just 1. Okay, so then, now let's go on to the second part. I am going to identify the zeros of this relation. So here, and here are the 2 points that represent my zeros. Right? Zeros are the ones that have a y value of 0, a y value of 0. So what I'm actually interested in, however, are the x values, which are 0 in this case and 2 in this case. So all I'm going to do is I'm going to use this information. I'm going to use the a value here. I'm going to use my zeros, and I'm going to put it all together. And watch how I do this. I'm going to write y equals 1. That's the a value. I'm going to start from the beginning, in that we have y equals a, x minus s, x minus r. That's normally how we write it in factored form. S and r represent the zeros. So if I put all the numbers in, y equals 1, x minus the first 0, which is 0. And then x minus 2. Okay, so really, when we're asked to write an equation from a table, we have to go through a few steps, but it's about that easy. Now, I would probably simplify this. I don't want to have, multiplying things by 1 is kind of pointless. Subtracting 0 for things is kind of also kind of pointless. So I would probably simplify this as y equals x minus 2. Okay, so that's my final going to do another example, and in this case I'd like you to take the lead. So again, be ready to pause the video, and I want you to go through the exact same procedure and figure out the equation, find your a value, identify your zeros, and write it out loud, okay? Pause the video here and do that. Okay, so how'd you get on? In this case, the a value was also 1. So a equals 1. And you get that from your second difference and that sort of thing. And our zeros are here -1 and here +1. So if I write all that out, starting with the basic equation, y equals a, x minus s, x minus r. And then I have y equals 1, x minus -1, okay? So be careful here. I have x minus a, we call that as a plus 1. So a simplified version of this would be x plus 1, x minus. Right? A few things to keep in mind here, a few things to keep track of. It's always x minus something, right? And the something is the corresponding x coordinate of the 0. So keep in mind this is always minus. Always minus. You're always subtracting. And I'll give you a sense of why that might be in just a few slides. Okay? Just for now though, x minus s, x minus r. Try to remember that. Okay, so before we go any farther, this next part, you'll need to know a new rule, and it's a rule that you probably already intuitively understand, but it's the rule of zeros. The rule of zeros. If you have two things, two quantities multiplied together, and your product is 0, then either the first thingy has to be 0, the first quantity has to be 0, or the second quantity is 0. Right? Those are the only ways you can multiply two things together and get 0. One of them had to be 0. Potentially both could be 0. But in this case, our understanding is that either the first quantity will be 0 or the second quantity will be 0. And really, you just know that because anything multiplied by 0 is 0. Okay. So, why does this matter to us? Well, let's consider that second example that you did from the exercises a moment ago. Our equation was y equals x minus 1, x plus 1. I think I have the order of these switched around, but it doesn't really matter. So at the zeros, remember from the table of values? At the zeros, the y coordinate or the y value is 0. So what I'm going to do is I'm then going to replace the y with a 0. So now I have 0 equals x minus 1 times x plus 1. And here's where that rule of zeros comes in. Because if these two quantities multiply together to give me 0, that means that either the first one is 0 or the second one is 0. So in other words, let me just get rid of this. Either you have x minus 1 is 0, that's the first term, or you have x plus 1 is 0, that's the second term. So then if you simplify the first term, you get x equals 1. You just add 1 to both sides. Or, if you start here, you subtract 1 from both sides. So this is your answer. You've essentially solved your equation, and you have two solutions. X equals 1 and x equals -1. And again, just bring it back, these are the zeros. These are the zeros. Okay? So if you're ever given an equation in the factored form, such as this, you can always figure out the zeros. You don't have to go through a table of values because that's kind of annoying after a while. You can just set y equal to 0, and then you realize that either the first term has to be 0 or the second term has to be 0, and you either go down this path and you say, okay, what is x on this side, or you go down this branch and you say, okay, what is x on this side? All right, so that's the easy way. That's an easy way of getting the zeros. You just set the first term to 0, you set the second term to 0, and you solve each of them separately. Okay, let's do one more example. This one's a little trickier, but you'll see that it's not too bad. So in this case, I'm not going to go through the table. I'm just going to state that this is the quadratic relation, and we want to find or determine the zeros. Okay, so again, this procedure works exactly as before. We know that at the zeros, the y value is 0, so we set y, that was up here, y, we set that equal to 0. Okay, and because of our rule of zeros, we can take each of these terms and set them equal to 0, like so. Okay, so now here's where things get a little tricky. Sometimes sometimes my students have had trouble solving this, but I mean, it's a linear equation. You know how to do it. You're going to, in this case, subtract 3 from both sides and then divide both sides by 2. Over here, you're going to add 4 to both sides and then divide both sides by 3. Okay, so in this case, let me just get rid of this altogether. So in the first case, I'm going to add 3 to both sides. So excuse me, subtract 3 from both sides, so I'll have 2x equals -3. And then divide so that x equals -3 divided by 2. And on the other one, I'm going to have 3x equals 4, x equals 4/3. So again, these numbers are your zeros. I didn't need to come up with a table of values. I just know that my zeros are at -3/2 and 4/3. Okay, so here's a little bit of practice. Grab a sheet of paper and pause the video and just state the zeros of each of these. Just state them, right? You don't have to do a ton of work. You'll probably get to the point pretty quickly where you can just look at the factored form and state what the zeros are. Okay, so most of these are pretty straightforward, but a few of them you may have a bit of trouble with. So I would say be careful with this one. Be careful with this one. I'm trying to fool you on those. But most of them are not too bad. One thing that you will want to know, I guess, before getting too deep into this, is that the a value doesn't actually affect the zeros. So I guess I'll go through one of these just so you can see that. So in the first one here, you have, if I set y equal to 0, you have 0 equals 2 x minus 7 x plus 4. And so then the first thing that you would do, now that you've set y equal to 0, you're going to divide both sides by 2, by the a value. 0 divided by 2 is still 0. And then this side, the right side divided by 2 is just the product of what we have. So in other words, this becomes 0 equals x minus 7 x plus 4. Okay, and from there you can just apply the rule of zeros as we've done before. Okay, so now would be a good time for you to pause the video, finish up that first one, and then try and do the rest of them as well. And I'll give you the answers in just, well, very shortly. Okay, so pause the video. Okay, so there are the answers. Again, a couple things that you'll want to watch out for is that in the third one here, I have this squared, meaning that although it might not look like it, there was actually two terms which are multiplied to give me 0, x minus 2 and x minus 2 again. So since those two are the same, they produce the same answer, that's why I only have 1, 0. Okay, so that one was a little tricky. Also, here I have x plus 9 multiplied by just x. So you might wonder, well, what do I do with that x? Well, that x, if these two things are going to be multiplied to give me 0, that x could be 0. So that's why x equals 0 is a solution. Okay? So it follows along, it follows all the same rules as before. It just looks a little strange when x is just hanging out by itself in the front. Okay, so don't be fooled by that. That's all for today. Thanks very much, and I'll see you in the class.